Our learning target today is to classify the types of chemical reactions. I told you we're going to be dealing with 5 different types. You can see on that paper I just handed out to you. They are called combination, decomposition, single replacement, double replacement, and combustion. So, in order to hit this learning target, to classify the types of reactions, we need to be able to do the following success criteria. Number 1, we need to be able to balance a chemical equation. We started doing that yesterday. Second success criteria is we need to be able to describe / identify a synthesis reaction. Now, you're going to see that we use synthesis as well as combination. I refer to it as synthesis because when we are naming the specific type of synthesis reaction, we use just the letter S. Now, why do I not use the letter C for combination? Because there's also one called combustion. I don't want to get those confused. So you're going to hear me identify this as a synthesis reaction. So we need to be able to describe / identify that. Also, we need to be able to predict a synthesis reaction. Now, what that means is, given 2 reactants, you can tell me what they're going to make. Okay? What they're going to make. So, here are some examples that we are going to work, and I'm going to show you how I want you to work these. So go ahead and write down aluminum plus oxygen. Now, as I'm looking at this, remember that oxygen is a diatomic. Okay? Aluminum is not a diatomic. That's why we do not have 2 of those. The very first thing that we need to do is we need to pick out what type of a reaction this is. So I'm looking right here, excuse me, if you look at your combination reactions, okay, if you look at your combination reactions, we have 5 different ones, okay? We have 5 different ones, and they're right here, numbers 1 through 5, okay? These are our 5 different combination reactions right there. We need to pick which one out of these 5 we're dealing with when we're talking about aluminum plus oxygen. So as I look, I just go through and ask myself questions like, number 1, is this 2 elements? Well, yes, it is 2 elements, isn't it? So it could be number 1. Is it a non-metal oxide and water? No. Is it an active metal oxide and water? No. Is it a metal and oxygen? Yes, it is. So that one trumps number 1. I said it could be number 1. Well, this is a specific one. So it could be number 4. And finally, is it ammonia plus acid? It is not. So what I'm dealing with here is I am dealing with this one right here. So as I go back, I'm going to write that this is a synthesis number 4. So when I come back here, I'm putting S number 4. So I know specifically that it's a synthesis number 4 reaction. Now, when I have aluminum and I add oxygen, okay, it's going to yield, it tells me on number 4, a metal plus oxygen yields a metal oxide. Check the activity series. So, here's my activity series. I need to check. What do I need to check? Well, there is this line on the activity series, and it says, reacts directly with oxygen, giving oxides. So I need to check Is aluminum above that line? It is, correct? So this reaction will occur. So once again, as I look at this, a metal plus oxygen yields a metal oxide. So this is going to yield a metal oxide. Now, specifically, what is my metal? Aluminum. So it's going to specifically yield aluminum oxide. Now, ladies and gentlemen, when I am doing these, I do it exactly like this because now I have the words aluminum oxide. I need to make sure I get the chemical formula correct. So this takes me all the way back to nomenclature. Okay? Aluminum. Well, aluminum is Al3 plus. Oxide is O, 2 minus. Are my charges equal? They are not. Okay? So what I need to do is I need to take both of those to 6. So I'm going to say aluminum oxide is Al2O3. Would you agree with me on that? I hope, because it's right. So now, here is what is being produced. So I'm going to come back up here. I'm going to clean this up. And I'm going to write here that this is producing Al2O3. So now I have my skeleton equation. Am I finished? No, because I need to do what? I need to balance this. I can see that I have an even-odd problem, so I'm going to put a 2 here to make my oxygens an even number. So that gives me 6 oxygens. Here I have now 6 oxygens, and if I put a 4 here, I have now balanced my chemical equation. Questions over that one? All right. Now let's look at the second one here. Okay, let me get this off of here. Let's look at the second one here. Calcium oxide plus water. Once again, I come back to these and I say, okay, I have 2 of them right here, these 2. A nonmetal oxide plus water yields an oxyacid, or an active metal oxide plus water yields a metal hydroxide. Now, I'm looking right here. I have calcium oxide, right? Is calcium a metal? Yes. So I'm dealing with a metal oxide and water. So as I come back here, I have now narrowed it down to right here, that I am dealing with an active metal oxide and water. Now, as I look on my outline, it says an active metal oxide plus water will yield a metal hydroxide, but it's only with groups 1 or 2 metals. So I need to look. Is calcium a group 1 or a group 2 metal? It is. So this reaction will occur. So I have a synthesis number 3 reaction in which calcium oxide reacts with water to give me a metal hydroxide. Specifically, what is my metal? Calcium, right? So it gives me calcium hydroxide. So now I need to go through and name calcium hydroxide. Well, Ca I know is a 2+. I know hydroxide is OH. OH is a 1 minus. So as I'm writing my formula, I can see that it's going to be calcium. I need my parentheses because I need 2 hydroxides. So when I go back up to clean it up, instead of my words up here, I am going to put my formula that I just got. Calcium hydroxide. I'm going to clean this up, get this out of there. So now I need to go back and check, is this balanced? Is this balanced? And as I look, yes, indeed, this is now a balanced chemical equation. Now, my third example here. N2O5 plus water. So once again, first thing I need to do is I need to determine which one of these synthesis reactions I'm dealing with. Is it 1, 2, 3, 4, or 5? Once again, as I look, I know I'm dealing with water. So it's either going to be a combination synthesis 2 or combination synthesis 3. So I need to decide what I have with water. As I go back, I see that I have N2O5. Now, is that a non-metal oxide or is that an active metal oxide? It is a non-metal oxide. So, for this particular one, I am making an oxyacid. So I have a synthesis number 2, a non-metal oxide plus water gives me an oxyacid. So I know that this is a synthesis number 2. So N2O5 plus water gives me an oxyacid. Now, what is an oxyacid? Well, it is an acid that has oxygen and usually one other element. In this case, it's going to be nitrogen. Now, how am I going to determine what my oxyacid is? Well, the easiest way I found to do this is I just take my N2O5 and I pretend that I'm adding H2O. So I come up with H2N2O. 5 plus 1 is 6. Now, can you see that I can factor a 2 out of that? So when I factor my 2 out of that, I'm going to say that this is HNO3. Now, does that make sense? Yes, it does, because the polyatomic ion NO3 is a 1 minus. So I would need one H to go with that. So as I come all the way back up here, I'm going to get this stuff out of here. And I know that my oxyacid that I created was HNO3, nitric acid. So as I'm looking at that, obviously I do not have a balanced equation, do I? Okay, but if I put a 2 here, 2 hydrogens, 2 hydrogens, 2 nitrogens, 2 nitrogens, 6 oxygens, 6 oxygens, and now I'm balanced. This is probably a synthesis number 2 is probably the most difficult one of all the synthesis reactions. Okay? Now let's look at this next example. Pb plus CS. Pb plus CS. Now, I go through. Is this 2 elements? Well, yes, it is 2 elements. Do I have a nonmetal oxide and water? No. Do I have an active metal oxide and water? No. Do I have a metal and oxygen? No. Do I have ammonia and an acid? No. Okay? So this is going to be a synthesis number 1, 2 elements. So as I come back, I say that this is a synthesis number 1. Now, looking at my outline, synthesis number 1, I can have either a metal and a nonmetal, which yields a salt. I can have a nonmetal and a nonmetal, which yields a molecule. Or I can have 2 metals, which yields no reaction. Well, as I look at this, I have Pb, which is lead. Cs is cesium. Cesium is an alkali metal. So for this particular one, I have 2 metals, don't I? So my outline tells me that if I have 2 metals, NR, no reaction. No reaction because I have 2 metals. Questions here? Okay. Now, my final one, my final example here, I put on here for a reason, and I'm going to show you why. Here we go. I have lead, and I have fluorine, which is indeed a super 7. So that's why it is diatomic. When I go through and ask myself of the 5 equations, the one that fits best is a single replacement, or excuse me, a synthesis number 1. So, I'm dealing with a synthesis number 1. So, Pb plus F2 yields. Now, it tells me that I have either a metal and a nonmetal and a nonmetal, or 2 metals. So in this particular case, I know that lead is a metal. I know that F2 is fluorine, which is a halogen. Halogens are nonmetals. So what I have here is a metal plus a nonmetal. So this is giving me a salt. What is my salt going to be? Well, it's going to be lead fluoride. So I put lead fluoride. Now, the thing about lead fluoride is that it can be PbF2. I could have lead 2 fluoride, or I could have PbF4. I could have lead 4 fluoride, correct? Because lead is multivalent, meaning that I need Roman numerals, meaning I could have 2 different ones. So, if I were doing this, if I were doing the first one, Pb plus F2, is that one balanced right there? It is. Okay? It is balanced. Could I also, though, have PbF2 to give me lead 4 fluoride? I could. Is this one balanced? It is not yet, because I need to put a 2 right there to balance that out. So, for this particular example, I could have that, or I could have that. I could have 2 answers. Now, how would I know which one it is? I would have to go through and do some testing. Sometimes it's as easy as looking and saying, okay, lead 4 is this color, lead 2 is this color. Okay? Sometimes it's that easy. But nonetheless, I could have both answers. Questions about that?